Hello all, so I'll be talking about the difference between an ideal solution model and a regular solution model. So let's start with what an ideal solution model is. So an ideal solution model assumes that there are no interaction between the components. So if you have a solution which comprises of two components A and B, the ideal solution model assumes that the bond energy between the A and A atoms, between the B and B atoms, and between the A and B atoms are same. So this implies that there is no attraction or repulsion between the A and B atoms, and therefore we can assume that the delta H of mixing is zero. The delta G of mixing would then turn out to be minus T into delta S of mixing, where delta S of mixing is given by this term. So this term represents the number of ways in which A and B atoms can be arranged, and therefore delta G of mixing would come out to be this term for an ideal solution. So let's see how to plot some of the important thermodynamic variables. So let's start with the entropy of mixing for an ideal solution. So as you can see over here, it is XA ln XA plus XB ln XB, where X is the mole fraction of that component in the solution. So now if we take the mole fraction of A to be 1 and mole fraction of B to be 0, then this entire term turns out to be 0. And similar is the case when xb is 1 and xa is 0. And the delta S is maximum when xa is equal to xb, and that occurs when the mole fraction is 0.5. So you would expect the graph to look something like this, where it reaches a maximum at the center point of the mole fraction value. And now let's start plotting the delta G of mixing. So that is nothing but the delta S of mixing multiplied by the temperature. And therefore you can see that it scales with the temperature. And you can also see that delta G is always negative for an ideal solution. So this tells us that a solution is always favored when you have A and B components in the mixture. So now let's start talking about a regular solution. So in ideal solution, we assume that there is no interaction between the components. So the regular solution model is an example of a non-ideal solution where you take into consideration the interaction that is taking place between the atoms. And the regular solution model is the simplest model for non-ideal solution. So it still assumes that the delta S of mixing is equal to delta S configuration, which is the same as what we took in the ideal solution model. But the only difference is that we also assume that the delta H mixing is non-zero and a function of the composition. So the delta H of mixing is taken to be a constant W into the product of the mole fractions. And this W can be either negative, positive, or even 0. And therefore the delta G of mixing term looks like this. So as you can see over here, this term is common for both the ideal solution and the regular solution, but the only difference is the delta H of mixing term. So this will introduce a difference in the behavior of the solution. So now let's look at the nature of the plots for a regular solution model. So we've plotted delta H of mixing with respect to the composition, and it will depend on the sign of the constant W. So for W equal to 0, delta H of mixing would be 0, and therefore it would follow the ideal solution behavior. And if W is greater than 0, then there will be a positive deviation to the ideal behavior. And if W is a negative term, then as you can see, it will be a negative deviation from ideal behavior. The delta S of mixing is always is the same as what we saw in the ideal solution. So now let's plot the delta G of mixing. So the delta H of mixing, as we've plotted, depends on the sign of W, and the minus T delta S of mixing will always be a negative term. So when W is equal to 0, it will follow an ideal solution, and when W is less than 0, the delta H of mixing would be a negative term, and therefore the negatives would add up and you'd get a even more negative term than the ideal behavior. And in the case of W being positive, there you can see that the slope curves up, and there are regions where the delta G of mixing is positive. In these areas, the formation of a solution is not favorable, and therefore here in this plot you can see the difference between an ideal solution behavior and a regular solution behavior, which is brought about when we introduce the delta H of mixing term.